Sec 3 NA Chapter 5 Coordinate Geometry, Exercise 5.1, Questions 6, 7, and 8. Now, in this part of today's chapter, we'll be reviewing the concepts of distance between 2 points. And not only just that, we will be using this concepts or other skills that we have learned to find the shortest distance from one point to a line, and to prove that triangles are right-angled triangles using the converse of Pythagoras theorem, and to also use the concept of distance between 2 points to solve algebraic equations. Now, without further ado, let's begin. Question number 6. In your textbook exercise 5.1, now the vertices of this triangle ABC are A is equals to -2, -1. For me, in order to get a clearer picture, so I tried to make a sketch to show you what this diagram looks like. Okay, and then B is 2, -1. Okay, B. So what do you notice about these two lines? The y values are actually the same, so we actually have a straight line over here, right? And then C is the point 1, 1, 3. So when x is 1, y is 3. So this is the point C, A, B, C. Okay, so we have our triangle ABC to look something like this. Find the lengths of AB, BC, and AC. So I'm going to find out the individual length. What is the formula to find length distance between 2 points? So if it's just AB, AB don't really need to use the formula, but if you want to use the formula, it's also possible. But as you can see here, we have the number from -2 all the way to 2. We just take 1, 2, 3, 4, and that will be 4 units. Okay, if it's not a slanted line, then we will need to use if it's a slanted line, we need to use the Pythagoras theorem. Okay, and then now BC, length for BC, B is the point 2, -1, C is the point 1, 3. So square root something square plus something square, y2 minus y1, 3 minus -1, okay, and 1 minus 2. So calculating this, we get the answer to be 4.1231 or 4.12 units. Alright, and next question, find AC. So we're going to find part of AC. AC is also a slanted line. A is the point -2, -1. C is 1, 3. So we need to use the Pythagoras theorem. Something square plus something square. So y2 minus y1, 3 minus -1. x2 minus x1, 1 minus -2. And I get it to be exactly 5 units. Now questions B asks us to find the area of triangle ABC. So for part B, area of triangle is half times base times height. So in this case, where is the base that we can find? One of the easier measurements, this can be our base over here. We know this is 4 units. If this is our base, this will be the perpendicular height. Correct? So if this is the perpendicular height, what is the height for this? How many units is that? We know that -1 to 0, 1 unit, 2 units, 3 units, and 4 units. So in this case, the area is given by half times a base of 1, 2, 3, 4, 4 units, and a perpendicular height 1, 2, 3, 4, 4 units. That gives us 8 square units. Okay, so now next question. The question asks us to find the length of the perpendicular from B to CA. Now in this case, I have this triangle over here. Okay, I know that triangle ABC has an area of 8 units cm square. So I'm going to draw out ABC, A, B, and C. This is for part C. I already know that the area of this triangle is 8 units square. Now they ask us to find the length from the point B, the perpendicular distance from B all the way to travel to AC. When you want to be perpendicular to the line AC, how do you travel? you need to move in such a way that is 90-degree perpendicular to it. If this is perpendicular to it, that means AC will now be the base, okay, of your triangle. And we know the base here, the AC, is 5 units. In that case, what is the height, which is this perpendicular distance from B to AC? So we shall let H be the perpendicular distance from B to AC. We know that the area of the triangle is given by 8 units square, 8 square units, correct? So area is given to will be half times base times height. And now the area we are given is already 8 from what we find in part B. Then half times the base is this number over here, 5 units. And the height we do not know, which is H. So now how do we find H? We need to undo half and undo 5. So I take 8, divide by half, divide by 5. So 8 times 2 divided by 5 will give me the number 3.2. So the perpendicular distance from B to AC will now be 3.2 units. Have you gotten the answer? Now let me repeat the concept again. I already know the area of triangle from part B. Area of triangle is 8 units square. So in this triangle here, area of triangle is also 8 units square. Right? And if I know I want to find the perpendicular distance from one point B all the way to the line AC, it needs a 90-degree. So that means this is my perpendicular height. And if that's my perpendicular height, this one will be my base. So area of triangle is half times base times this height. So that's why I can use this equation and I get H to be 3.2 units. Have you gotten the concept? Okay, next question, question number 7. The vertices of a triangle PQR are P negative 4, 4, Q 4, 6, and 5, 2. Now, in order to help you to visualize this diagram better, so I just roughly make a sketch over here. So this point P will be negative 4, 4, right? Point P. And point Q will be 4, 6. 4, 6 is slightly higher. Then the point R is 5, 2. Right, so I will have a triangle that looks something like this. Okay, now question says 7a, find the lengths of PQ and PQR and PR. Now we notice that none of these are horizontal or vertical straight lines, so we cannot use counting. So we have to use the Pythagoras theorem for all the lines. So PQ, P is the point negative 4, 4. And Q is the point 4, 6. So we shall use our formula, something square plus something square, and that gives me y2 minus y1, x2 minus x1. So 4 minus negative 4. Okay, and we get the answer to be... Notice that in this case for part B, right, they ask us to show that this is a right angle triangle. So that means I will need to use the length of these 3 numbers. So for me in this case, I will especially instead of just writing in decimal place, I'll specially write down this is actually square root of the number 68. Then I'll write it in 5-6 form and then 3-6 form. So I got the answer 8.246, 1, 2, 3, 4, 2 units. And then round it off 8.25 units. Right? We'll do similarly something for QR and PQ as well. So QR, it will be equals to something square plus something square. Like I repeat again, since I need to use the length later to show that it's a right angle triangle, so I'm going to find the square root of the exact number first. Okay, QR, R is the point 5, 2. So y2 minus y1 over x2 minus x1. So that will give me square root of 17, which is 4.1231, and then 4.12 units. Right, and then I will need to find PR as well. PR, or RP actually, not PR. RP. So RP will be square root of RP, so y2 minus y1, 4 minus 2, x2 minus 1, minus 4 minus 5. So like I mentioned, we'll need to use the numbers later, so I try to put the exact value in my question over here. So be negative 4 minus 5 whole thing square plus 4 minus 2 whole thing square. And that gives me square root of 85. That means this is actually the longest length. Square root of 85 will give me 9.2195, rounding it off, 9.22 units. Okay, so as such, I found the length for all the three sides of the triangle. Now, question part B, show that triangle PQR is a right angled triangle. Do you still remember how to prove that a triangle is a right angled triangle? Well, we are going to use the converse of Pythagoras theorem. Now, in this part of proof, please follow the writing properly. Now, we know the certain length. Okay, we have this three length, PQ, QR, and RP. We should start with the longest side. Which is the longest side in this case? That will be RP, isn't it? So we'll start off our converse of Pythagoras theorem in the following way. RP square is equals to square root of 85 holding square, which gives me the number 85. Please do not start with a square equals to c square plus b square. That is wrong. We will be assuming the Pythagoras theorem directly. So we need to prove. So we need to show that RP square is equals to this number square. Then next, where is the sum of the other two sides square? I have the other two sides, PQ square plus QR square, the other two slightly shorter sides. So I'm going to take PQ square, which is square root of 68 holding square, plus square root of 17 holding square, and it gives me the number 68 plus 17 to be 85. So you notice that I have two numbers which are 85. So since this is true, so I start to write the converse of my Pythagoras theorem. Since RP square is equals to made up of the other two shorter sides, PQ square plus QR square by converse of Pythagoras theorem, okay, triangle PQR is a right angle triangle. Okay, so we have just shown that this triangle is a right angle triangle, and I will only accept this method of proving. Alright, please follow accordingly. Now let's continue with part C of the question. I already know the length of PQ to be square root of 65, and length of QR square root of 17, and in this case they asked me, and that this is a right angle triangle. Find the area of triangle PQR. I need to know the 90 degree. If triangle PQR, PR is the hypotenuse, which means this is the longer side, then where will be the 90 degree? The 90 degree will be the side opposite to the diagram, okay, to this line over here. So that means this is going to be the 90 degree. If this is the 90 degree, how can we find the area of this triangle? Area of triangle will now be half times base times height. Where will be the base? This will be the base. And where's the height? This will be the height. So area of triangle for part C. Area of triangle PQR will be half times base times the perpendicular height. And that will give us, in 5 sig fig, 16.6 units to 3 secant figures. Okay, 16.6 units square to 3 secant figures. Now, next part, D. If PQRS is a rectangle, state the coordinates of the point S. So now I have this diagram over here, PQRS to be given as a rectangle. So I have tried before how to find a parallelogram, right? The fourth point of a parallelogram. So from my questions, we can see that point P is the number -4, 4. This is for point P. It travels to Q, P, Q, R, S, right? To Q, Q is 4 to 6. Then it goes to R. R is actually 5, 2. That means in order for it to be a rectangle PQRS, P to Q, Q to R, R will now need to go to the point S, which is somewhere along this area. So S will be somewhere along here. How can we travel? Now, P to the point S is the same as Q to the point R. Okay, so I'm going to analyze a little bit using my points from Q to R. Okay, so Q is the X number is 4, Q to R, that means I travel by 1 unit on my x-axis. And then I travel from Y6 down to R. That means this one from 6 become 2. That means I go down by 4 units. So in summary, it means for my x coordinate, I will plus 1. And for my y coordinate, I will subtract. From 6 become 2, so subtract 4. So if I have the point P, P is given to me to be -4, 4. How do I get a point S? I need to take the x coordinate -4. I plus 1 to it. And then for my y coordinate 4, I need to subtract 4 to it. Okay, so I'll have point S to be -3, 0. So this will be the coordinates of point S. Have you gotten the concept? Okay, question number 8. Now, question number 8 is something that we have done previously before. Given that the distance between 2 points is 5 units, so find the possible values of K. So in this case, I'm going to find out the distance between these 2 points. So if I want to find the distance, I'll need to use the Pythagoras theorem. So something square plus something square square root is equals to 5 units. This is what they gave us, right? So we're going to put it inside y2 minus y1. So I'll use k minus 2 so that I don't get k to be negative. x2 minus x1, 1 minus -3. Be careful of the working itself. So this one, now I don't want the square root over here. So how do I undo a square root? I will square both sides, right? So in this case, when I square both sides, the square root will disappear, and 5 will become, 5 square is 25. And this number will remain as something square plus something square. So here is k minus 2. Let's do a little bit of simplification. 1 minus -3 become 1 plus 3. So that means it's actually 4 square. 4 square is the number 16. So I have k minus 2 square equals to 25. Okay, do you remember like the time when we solved completed equations involving completing square? Now I can have k minus 2 square. I will bring the 16 over to the other side. Okay, so if I do that, I will have 25 subtract 16. So I'll get k minus 2 whole thing square to be equals to the number 9. Now, when I need to take square roots, so after I take square root of 9 will give me how many answers? I have 2 answers, right? I'll have positive 3 or negative 3. And after which I find value of k, that means I'm going to add a 2. So 3 plus 2 or negative 3 plus 2, which gives me a value 3 plus 2 is 5, or the number negative 1. Okay, so this is something quite familiar that we have done before. Hopefully you can recap and remember a little bit. Now we come to the end of today's part of the lesson. Let me go through a little bit more to summarize what we have learned for the day. Here's a summary of the skills that we have learned for today. Now, the distance between 2 points is given by the formula square root something square plus something square. That looks like Pythagoras theorem. So y2 minus y1 square, x2 minus x1 whole thing square. Okay, the shortest distance from one point to a line. Now what we use for today is to use the concept for area of triangle. So if this is the triangle, okay, I can find the area of triangle by using half times base times perpendicular height. Okay, base and height. But now if I were to have the same triangle, but now they ask me to find the distance from one point to a given line. Okay, let's say point B to AC. The area will stay the same, but this perpendicular distance now changes to here, and the base will now be AC. Okay, so what we can do, we are going to use area of triangle is half times base times height. Just that we find a different pair of base and height. Next one, to prove that triangles are right-angled triangles, we are going to use the Pythagoras theorem, but we do not start with a square equals to c square plus b square or anything like that. We will always start with the longest side square to be equals to some number square to be equals to one number. Okay, and then I'll take the other two sides, the shorter side. So side 1 square plus side 2 square to find that is something square plus something square equals to a particular number. And check that since these two numbers are the same, by the converse of Pythagoras theorem, the triangle is a right-angled triangle. Means we will have the longer side square equals to something square plus something square. Then we will write by the converse of Pythagoras theorem, then triangle what is a right triangle. Okay, and last but not least, we have done and go through the questions on solving algebraic equations. Just remember, it's a quadratic equation. When we take square root, there will be two values to it. Right, now this is the end for today's chapter. Please make sure you write all these questions into your math exercise book. Now see you for the next lesson.